All right, in this lesson, students will solve for unknown angles and triangles using some triangle theorems. So we're going to first define interior and exterior angles. So interior angles are the angles inside a polygon. If it's a triangle, then it's the three angles. A triangle has three interior angles, but any regular polygon, or any polygon, will have interior angles. A regular polygon has all the interior angles the same measure. Exterior angles are angles formed by a side of a polygon and a side extension. So you take one side and you extend it. Let me show you what that looks like. So if I draw a triangle and I extend that last side, this is the exterior angle. Okay, so I can kind of mark that off. That's the exterior angle. And that's true for any polygon. If I try to draw my pentagon here and I extend a side, then this is an exterior angle. So another thing to note, one interior, so one interior and one exterior angle in a polygon form a linear pair. Okay, because if you look here, here's one interior, here's the exterior, together they form a line. Same thing up here, doesn't matter what the shape of the polygon is. Here's an interior, here's the exterior, they form a line. So in general, any interior, a single interior and a single exterior will always add up to 180 degrees. So next we're going to talk about and then prove what's called the triangle sum theorem. And I think you already know what this is. So the theorem states that the sum of the interior angles of a triangle is 180 degrees. And we're going to prove that because that's what we do in geometry. We prove things. So if we are given triangle ABC, so I'm going to draw it. Here's triangle ABC. And then I'm going to number the angles in here. 1, 2, 3. Okay? We want to prove the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to 180. So there's our starting point. We're starting with triangle ABC. That's given, and we know what our endpoint needs to be. Well, I'm going to use what we know from parallel lines. Okay, so here's what I'm going to do, and I know that you probably wouldn't know to do this, but I'm going to draw in an auxiliary line. You can do this, and I'm going to call that, well, it's just, I don't even know if I need to label it. Yeah, I'm going to put a point D on here. Okay, so I'm going to draw AD, and it's going to be a line, so I'll put arrows. And the requirement here is I'm drawing AD so that it's parallel to BC. And the reason I can do that is the parallel postulate from the other day. Okay, the parallel postulate states for any point not on a line, there's exactly one line that can be drawn through that point parallel to the given line. So that lets me do that. Okay? So here's some things I know. I'm going to number a couple more angles here. I'm going to call this one 4 and this one 5, and I'll put A up there because that one A is kind of in the way there. Let me fix that because it bothers me if I can. Oh, my eraser doesn't erase very well. Make it bigger. No, I guess it's not going to do that for me. Okay, never mind. All right, so next thing I'm going to do, since I have that, a couple things I know. I know that angle 4, 2, and 5 add up to 180 because angles on a line add to 180. So the measure of angle 4 plus the measure of angle 5 plus the measure of angle 2 is equal to 180. The order doesn't really matter there, okay? Angles on a line equal 180. The other thing I know is alternate interior angles. So when I have these parallel lines here, 5 and 3 are alternate interior, 4 and 1 are alternate interior, because there's your zigzags. So I'm going to write two statements in line 4. I'm going to say the measure of angle 5 is equal to the measure of angle 3, and then the measure of angle 4 is equal to the measure of angle 1. And that is because alternate interior angles are equal. Okay? So once I have that, I'm trying to prove that these three angles add to 180. So I have this statement. I can replace angle 4 with angle 1. I can replace angle 5 with angle 3, and then I'm going to rearrange it so it looks like that. Okay, so my final statement, the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to 180, and that is because of substitution. So that is a proof, so that proves the fact that the angles in a triangle will always add up to 180. So now we're going to develop another theorem. If I look at this picture, I have a triangle, I have my 3 interior angles labeled, and I have my 1 exterior angle labeled. And I'm going to write some statements from this triangle, and we're going to develop a theorem from it. Okay? So the first thing I'm going to start with is the fact that angle 1 and angle 2 are a linear pair. So they're going to add to 180. So that's what I can say. I can say the measure of angle 1 plus the measure of angle 2 is equal to 180. You can either, the reason could be linear pairs add to 180 or angles on a line add to 180. Either way, linear pairs add to 180. Okay? And then I can use my triangle sum theorem to say that these 3 angles add to 180. Since I've just developed that theorem, I can say the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4 is equal to 180. That is the triangle sum theorem, but if you can't remember that, you can just say angles in a triangle equal 180. All right? Well, when two things are equal to the same thing, they are equal to each other by substitution. Let me move it down here so I have some room. So here I can say the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4. And that is substitution. Okay? See how I abbreviated that? And then if you look, I have the measure of angle 2 on both sides, so I can subtract that away, and that's going to lead me to a new theorem. The measure of angle 1 is equal to the measure of angle 3 plus the measure of angle 4. And that is by subtraction. So when you do your own proofs, eventually make sure I understand the difference between substitution and subtraction when you abbreviate. So what we just proved here, the measure of angle 1, this exterior angle, is equal to the sum of the 2 remote interior angles. If you look at this, angle 1 is equal to angle 3 plus 4. So that's called the exterior angle theorem. Okay, and here's what it says. The measure of a triangle's exterior angle equals the sum of the 2 remote interior angles. So angle 1 is going to be equal to 3 plus 4. So now we're going to work some examples. The first one here, I have an exterior angle. I have these 2 angles. Find the value of x. This is pretty straightforward. Just from the exterior angle theorem, I know that x is going to be 60 plus 40. So x is 100 degrees. If I had to write a reason, that's because of the exterior angle theorem. That's what it's called, and that's how you can abbreviate it. The second one, again, uses the exterior angle theorem. Here it's a little bit more algebraic. I have a triangle, I have an exterior angle. This angle is 3x minus 20. This angle is 2x plus 10, and angle M is 20 degrees. So these are angle measurements. These are not side lengths, okay? I'm going to find the measure of angle N. So I need an equation to solve for x and then to substitute back in. Well, using the exterior angle theorem, I know that 3x minus 20 is equal to 2x plus 10 plus another 20. The exterior angle is equal to the sum of the two remote interior angles. Okay, so if I subtract, I have 3x minus 20 is equal to 2x plus 30. So I have x is going to be equal to 50. What I want to find is angle N, so I have to substitute that in. Okay, so the measure of angle N is going to be 2 times 50 plus 10. So that's going to be 110, the measure of angle N. All right, we're going to work through one more proof here. And in this proof, we are given right triangle ABC, and we specify that angle B is 90 degrees. We want to prove that A and C are complementary, meaning they add to 90. So we start with our given. Let me stop. Right triangle ABC. I need a bigger eraser. Okay. Right triangle ABC. That's given. And the measure of angle B is 90 degrees. Okay. So what we know from the triangle sum theorem is the measure of angle A plus the measure of angle B plus the measure of angle C is 180. So that's the triangle sum theorem. That's how you can abbreviate it. But we also know that the measure angle B is 90. So by substitution, I can say the measure of angle A plus 90 plus the measure of angle C is equal to 180. So that's substitution. Then I can subtract the 90 from both sides. And I have the measure of angle A plus the measure of angle C is equal to 90. That's subtraction. Finally, by definition, I can say that angle A and angle C are complementary. Okay, that's a definition of complementary angles. So, that's our new theorem. In a right triangle, the two acute angles are complementary. So we can write that down, and we have another theorem we can use. So we can use that in our last example here. We have a right triangle. The angle down here is 2 times the quantity z minus 12, and the angle above is z plus 15. I want to find the value of z. Well, based on that theorem, we know that these two acute angles are complementary. So z plus 15 plus 2 times z minus 12 is going to add up to 90. So I don't have to do the 180 and subtract the 90 away. And now we just solve for z. 2z minus 24. So let's see here. We have 3z minus 9 is 90 So 3z, if I add 9 to both sides, that's 99. And z is 33. So those are samples of all sorts of different problems you're going to solve with triangles.